Hello everybody, it is Mike Levin on Thursday, August 4th, 2022. And on my last video, I used the schedule module from the Python packaging index site, meaning I pip installed schedule, and I switched from their default API, where you list scheduled events on separate lines, to using decorators, to where you put the scheduling events above the functions being scheduled using this little @ sign before functions that get imported, like here. Here's every, repeat, run pending, and cancel job, and those get sprinkled throughout here in order to achieve the kind of scheduling that I needed, including running something once and canceling it, all kinds of stuff. So I added as a bonus at the end of the video showing you how to make a persistent dictionary. And in the code that's running, I just sort of gratuitously, by the way, the code is running on containers, so I can show you the containers on my system right now with LXC list fast. And I've got right now 4 containers on my system. One of them, called Munchkin, is actually running. And it's not running the service yet because I turned it off, except in the work yesterday, I can show you where I incorporated all this stuff in. So it jumps me to the bottom of the file, but here's all my imports for the scheduling. Here's the ability to load things externally. And here is a function I made to calculate seconds from now for scheduling. And then I'm repeating every 10 seconds the function hello. I'm repeating every 5 seconds the pulse function, which is just a heartbeat and a log file type thing. And then I am sending mail once towards the beginning of the process, 11 seconds in, and then canceling it. And then I go into a busy loop here, which runs pending. So it's a busy loop that checks what's in the schedule every second. So you might notice that it's kind of annoying that when I do this highlighting here, it looks so ugly. And when I do that on my host system here, like say in my journal, it actually looks quite nice. I have the color coding worked out so it's readable, all green lantern and stuff. So that's because of my vimrc on my quote local system. And I made these files really easy to move around. So I figure I'll start there. I've got a vimrc sitting here, which is my good one, on my sort of Linux host system, not the containers. These are the containers up here. This is sort of the Linux host. But they all share that data folder. So if I go to just an empty Windows screen and do Windows key E to pull up Internet Explorer, not Internet, it's File Explorer. Boy, Microsoft really mixed all these words together. And I go into my data, my D drive. This is shared between all my containers, my Linux host, my clearly Windows machine. So I can just cp.vimrc ~/data. Bam, my vimrc appeared there. And now that it's in there, I can quit out of vim here, and then I can cp ~/data/.vimrc to ~/. And now when I go back into Vim Scheduler, it's with new color coding, and it looks a lot nicer on the container than it did. It uses my host machine's color coding, so I can now illustrate things to you, highlight them, and they're still readable. So that's important for the concept of sharing a data location between places, because that persistent database trick I threw in here with really nothing. I'm just opening a file called cats.db in the same directory as the repo. Notice no path name here. and then I'm saying a date stamp value is equal to foo. And that was just to get a little bit of persistence, to demonstrate persistence to you. But that's a really silly way and place to put persistence in an application like this that's emailing me pictures of cats, right? So clearly the database should be containing the image of the cats. And the primary key of the database is the trick I want to show you today, the primary key of the database. And I'll be doing this for the first time. This is unexplored territory for me. Conceptually, I always knew this should be possible and a good idea, but in actuality, I have never really done it. So just to remind you what's really going on here is this is a service that is being tied to Linux as a service, right? Because right now it's just recognizable Python code. It's a .py file, right? So how do you make a .py file into a service? Well, you just put another file on your Linux system in a special place. It happens to be in, and I guess I'll show it over on this side since I have these two things. cd /etc/systemd/system. And you can see the services that are on the system. The one that ties this file, this Python scheduler file, into the greater Linux operating system is this file here, which we can take a look at with sudo vim scheduler.service. And that's the file. See this file here? This file here points to this file here. And because it's in that magic location, and because this file is in that magic location, the systemd API can now treat it as a system service. So Python is acting as a Linux system service without a single line of bash code, without a single line of the old way that you had to do this under sysv. So this is new world stuff. This makes all kinds of wonderful things possible in Linux for the noob, for the average person like me. I am not, as much as people like to comment in my YouTube comments, I am not Guilfoyle. I am not that level of sys person. I do other stuff. And I use technology in the course of doing other stuff. But this is part of that technology that is so important. This is taking control of the machine at the moment it turns on. So let's start that service, clear. And we use that same systemd command or systemctl command, that same one. Did I use it at all? I first can use systemctl to check the status of the service, which is called scheduler. It's loaded, but active failed. It's not turned on. I know for a fact I stopped it. So I hit Q to get out of that status mode, and I do sudo systemctl. Oh, first a before screen ls. There are no sockets to the screen server, right? No sockets to the screen server. That's GNU screen. We start the service with sudo systemctl start scheduler. Now I look at the screens, and there is a screen there. There's a screen called scheduler, and I can connect to it with screen -r for reattach scheduler. And now you can see the pulse service has started. You see the first timestamp. You see a hello world. You see the second timestamp. You see sending email. And then you see the third timestamp, and then it'll go back and forth between hello world and timestamps because the email just gets sent once because that's how I defined it over here. send mail, repeat every day at 11 seconds from now, which means 11 seconds after I started it, and then cancel job. So 11 seconds after I start the service, this email gets sent and not again. So there's a few things I think I could do better about this system to make, well, it's not to do better about the system, it's to make this persistence trick have a meaning in life and be a profoundly cool video, and to get rid of this sort of arbitrariness here and use it in this system where persistence of a database could be really useful and cool. Why? Because when I download from this cat does not exist, that image, in addition to just being sent off in an email, could go into a database. The primary key for that cat record in the database could in fact be a perceptual image hash of the picture of the cat. Therefore, showing all the database keys would be the same thing as showing thumbnails, a directory of thumbnails. Do you get that? Because the primary keys are tiny versions of the image itself, showing the keys is like showing little pictures of all the cats, and you could use them kind of like thumbnails in apps that you build. And because the primary key is a perceptual image hash, and databases can't have more than one of the same primary key, it's a unique constraint, it will have the tendency to naturally dedupe the database. This is awesome! So, what we're going to do is move this little bit of code that has really no meaning here. It's kind of stupid. And that will keep that database thing from being created now. And let's see. I'll quit out of it. We're in that location, so if I ls there, you'll see the database that used to create locally. That's cats.db, right? So I'm going to remove cats.db. It does not need to be there. And we're going to put that persistence of, that persistence over here in send cats so that it makes a database entry, but it's not going to do it locally into this directory. Remember how I moved the vimrc file around? cd:/data ls ls-la for invisible files. There's the vimrc I moved over. So this now is going to be a logical place to put the database. So it will be accessible and in common between all my different containers, the Linux host, the Windows host. Okay, so I don't like the line wraps here, is written to blah blah blah. That's sort of ugly. So I'm going to go back to that directory I was in. I guess I was just trying to cd:/GitHub scheduler, vim scheduler, and written to. I'll just put the word logged in there. Control C. Wait at least 5 seconds. Bring it back up. Service restarts, because that's what services do. They restart. And there you see it says the word logged. And it no longer has the attempt to create cat.db there. So the email gets sent. I do an ls here, and cats.db has not gotten recreated here. So we'll leave this running for a little while over there. That's kind of cute over there, right? Let's see if I can Let's use arrow snap to see if we can tie these screens together. Sometimes when you use arrow snap to do that, and then you do the resize, it resizes both, but not in this case. Okay, not always what it's cracked up to be, but this is a good sizing to do these examples. All right, so we are going to go into sendcats.py. And we're going to refresh ourselves what sendcats does. Maybe I'll refresh you on sendcats by doing it from Jupyter here, because I do have that loaded. Does not exist. This cat does not exist. So every time you execute this code and then execute this code, you have a different cat image, right? Boom. Boom, boom. New cat. Boom. Oh, I keep making that same mistake. Why is Shift Enter? Oh, I'm not doing Shift Enter. New cat each time, right? So I had some duplicate cats, so I'm going to fix that problem at first. I'm going to go over here, and in the spot where it fetches the different cats, it's just a quick range with 3 rapid HTTP calls. So I'm going to import sleep. We could use sleep up here from time import sleep. And now we can go to where the cats are downloaded. You can tell because of the requests object in there. This is what makes the HTTP request. It's like loading a web page. I'll just put sleep, 3 seconds between loading cats is plenty of time. So let's see here. I am going to pause the video for a second. I paused the video so that I could bring up my email program here, the one that I don't use very often. I can see one of my YouTube viewers sent me an email on this, so that's really awesome. I'll read that and respond to Jens. But I need this here so that I can show you that when I run this program, now we don't really, the service is a little distracting. Control AD to detach from the screen. Clear system, sudo systemctl stop scheduler. We don't need it running all that much. In fact, I want to run this program over here, so it could be useful just to cd to ~/GitHub scheduler and to use the long path to the executable, which is home user, no, it's home Ubuntu Pi 310 bin Python 3, and then we're just going to run the cats directory, the cats file itself. So this one here, if we do a :E, we'll see the file name. It's sendcats, right? So I'm going to Python 3 sendcats. This is a before and after. Here's the before. And also, we fast forward a little bit in time. I have looked ahead and done a little bit of planning on my next step, but still we're going to do the before and after. We run the program. It reaches out, gets 3 new pictures of cats. Sends the email. And there's the after. So we've got another set of 3 cats. But inside this cat zip, it's cats1.jpg, cats2.jpg, cats3.jpg. Those will keep overriding each other. And if I get 2 pictures of identical cats, that's an issue too. So what I'm doing is I'm going to be doing perceptual image hashing for the primary key. So what I've done, this sort of look ahead thing here, is instead of just writing out the binary of the requests, this cat doesn't exist, into a file named cats.jpg, I create a variable name, so I use that for the file name, which is fine. But then I also have it available so that I can use that binary here in a database. And I'm still using the file name as the key. That's actually what's going to change. But before I change that to a perceptual image hash, I will show you here me creating a database. Now, instead of on the container, this path here is going to put it onto my network, which is also accessible for my DOS machine or for my Windows machine. So you can see here there are 3 files that I'm keeping in my common location. And after I run this script again, there should be a 4th file called cats.db. And that 4th file should be able to be something, that should be able to be reached from here inside Jupyter Notebook. In fact, I did the work ahead of time to ensure that it will be. So that file I'll be creating, I'll be reading off of the D drive on the Windows side. So it's not exactly operating system independent code, but it does show how these images can flow around, and I don't really rely on the emails when I've got the network connectivity. So without further ado, with those lines being uncommented out, I will run this again. And the email will be sent, but also cats.db just got created here. And in a moment, its file size should grow to approximately about the same as what attachments are. The zip files are about 500K. And here, the SQLite database, that's a SQLite database, is about 500K. So I know it's there, it's on the network. And being on the network such as it is, to access those cats, now I can go into Jupyter. And here in Jupyter, I am importing the display function of IPython, which I didn't used to be. I was just pulling in the image, but now I'm pulling into display because I need to use it here to display each image of the binary data of the cats, which I'm pulling out of the database. So before I show you that really awesomeness there, we'll import those 2 libraries, and then I'll just show you with SQLdict catsdb for key and database print key. There's the 3 file names of the cats, which are used as the primary key in the database. Now I can populate that into a file binary, see, by plugging the key into the file handle that is the database. It looks a lot like Python dictionaries. Now still, it didn't display them, but each time through the loop, it's got the file binary there. And if I unformat this display command, there's our 3 cats, the 3 new cats that were just fetched. They're also in my email here, in that new message that arrived. If I were to look inside of that zip, you would find the same thing. But now here's the interesting part. Instead of those file names, because those make terrible keys because they'll keep overwriting each other and allow duplicate cats in, this is the importing of PIL, which is a image processing library in Python. This is the importing of image hash, which I had pip installed image hash prior to this. And this is just a way to deal with bytes as I/O. I just had to do my research to do that. So you'll remember when you go through a loop, whatever's left over is still there in memory, in scope. It's a Jupyter advantage. So you can see, I'll just do these imports, and then I'll move this up here just to assure you the type of file binary is bytes, and that is what's sitting around to be able to be shown. I can just do image around file binary and it shows the cat. I can also use display there, which you actually have to use if it's not the bottom line of a cell, and that'll do much the same thing, just so you understand what's going on here. and I'm making a variable called file.io equal to pill image open bytes.io file binary. And then I'm image hashing that file.io, and we get what should be a little thumbnail image, but I've had very bad luck in displaying it. I can't display that thumbnail image. That is not the thumbnail. That's just another. So I've done various attempts to display the image here unsuccessfully. So I'm going to stay away from trying to display the hash as a little thumbnail. I think that's an idea for later. But this will turn out the same for every cat image it's applied to. Given the same cat image, the hash will turn out the same. It's a perceptual image hash. It's p hash. So what the heck am I doing there? And why in my download directory is there Alice and Carrie, whatever her name is? Well, it's because as you go researching this image hash, this thing that I pip install image hash, you're going to find there's different hash algorithms that can be applied. There is the average one, which is fastest, the perceptual one, which is good for creating little thumbnails for comparing things, and there's a few others. And when you follow the link here, when you follow the link to phash to read about it, you get this incredibly epic page. It's been around since May 2011, where they talk about perceptual image hashing using Allison Hannigan, I guess from Buffy, telling about the process, reducing the size, turning it to black and white, turning it into a hash. So that's basically the number we're looking at there. A number like that is what we have there. And you can do comparisons between things. You can see how close they are as a match. And the discussion that ensued here is 10 times longer than that seminal post on Python. It's not really Python so much, but as perceptual image hashing. But it's available real easy now through Python. And there's also wavelet hashes. I investigated a few different things. I even looked at the source code to see if I could figure out how to show a perceptual image hash as a thumbnail to no great effect. But now that we've got that, we can start transposing this back over to where we need that image hash for primary keys in a database. So you'll remember the lines I just edited out, or edited in as the case may be, are the ones that actually write to the SQL database, the SQLite 3 database on the network, right? See, there's the data folder right there. That's what's ending up with this over here. So what I do is I go to the top of that file and I put our imports in that we're going to need. As usual, my copy was inadequate. Copy, 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 copy. And there they are. So we now have the pill library, the image hash library, and bytes.io. I'll fix that sort order in a moment. I'll save that. And now with those available, I can go down to where I'm doing this, and you'll notice the context manager is being used twice. This is once for the writing of the file that will go into the zip file, and then this is the writing of the database, which will go onto the network. And we need to replace that file name with something else, and file binary is what's going to be fed into the image hash algorithm. So we can do that right around here because we're going to need it around there for each cat fetched. So we fetch the cat. This is the response equals request.get. This cat does not exist. And somewhere around here, we can do the same code as I'm using here, which is really not very much, right? So we create this file.io. I don't even know if that's the right name. Bytes.io, file binary. what it's ready for hashing. Yeah, it's ready to hash. Hash. And then this is a p hash. That will be much clearer to me. Still runs exactly as it should. And so these two lines are what go over here now, so that we have a perceptual image hash of each cat while we need it. And that's really interesting because it can become both the key in the database, right? So we replace this with AP hash. And to show you, oh man, to show you what's really going on here, this is such an interesting thing. Okay, fine. See this cats.db? We can access that and manipulate that a lot like we do, I don't know, Microsoft Access files or stuff. So I'm going to load SQL. This program I just loaded is DB browser for SQLite. Now I can do File, Open Database. And I wrote the database into my D drive. So I go to my D drive. I open cats.db and we go to browse data, and you can see cat1, cat2, cat3, and they're all in there as binary large objects, BLOBs, binary large objects. That is the actual data of the cat image. That's what the blob is there. It's a bunch of binary data. It's not directly readable here, but you can see the key value stores, key value, key value. We're going to replace cat1, cat2, cat3 with image hashes. And I have to make the decision whether the image hash is going to have the .jpeg in there to have the full image, but probably not. So we'll close out of that because we'll be going into it in a second. You're going to see this has made me use the image hash, the perceptual image hash, as the key. So it's already done. The work is already done. But the file name, we probably would rather, interesting. So I'm going to move the hashing up where the file name is required and get rid of a bug that I'm potentially doing because we're going to need that file binary. So as soon as the response is made, the file binary is made from out of the response, and the ready to hash value is created from the file binary, and then a perceptual hash is created from that ready to hash object. All right, so this is functionally text, a hash image. It has been converted down to be, 64-bit text or whatever. So anyway, our file name no longer has to be cat-I. Curly brackets are still good, but that can be a p hash. So that will use as the file name the hash.jpg. The extension is actually important here because we want to keep it as being a JPEG image in the zip file, on the drive, whatever. But we don't need the .jpg extension using it as a database key. So I'll keep this here because it'll fetch 3 different cats. It'll just use a different key system. So that file, when we reload it, will actually be a nice before and after. And this should actually have done it if I've pip installed the image hash and stuff on the server. I'm not sure if I did. So let's try running it. Yeah, no module named pill. So like we did before, I have to source /poly 30 310 bin Python 3. No, activate. So now that we're source. Did I not do that at all? Source. Oh, I had a parenthesis. I had a exclamation point instead of a tilde. All right, so now we're in our virtual env, and I can pip install, and I think it's just pill, so I need to double check that. Google will, of course, correct me if I have it incorrect. It is, in fact, pillow. Pip install pillow. Glad I checked. I wish they had some more use there to make sure. Yeah, that's it. Of course, that's it. I guess we can stay in the virtual env to double check this. No module named image hash, so that's going to be pip install image hash. Ooh, that has a lot of stuff with it. In addition to p hash, they have, I think it's w hash for wavelets, which might be a little more accurate for comparing things for differences and stuff. So there's a lot of interesting possibilities here. It's not merely about the perceptual image hashing that I'm using and tend to prefer and gravitate towards, because I have aspirations of generating little thumbnail images off of all of these. All right, so that requirement has been added. Let's try again. And now it looks like it is in fact running. But it's not. And I need to make this bigger to see the error. Clear, rerun it to get the whole error. And I should probably get out of the virtual env, but I might need it for a little bit. Clear, pipe the output to less so I can see the whole friggin' thing. Unsupported parameter or something along those lines it said. So let's just take a look over here. I might be doing something wrong. Nah, come on, I need to see that error. All right. Inner exception. Threading. Outer stack. Send cats line 84. Yeah, okay, db. APHASH equals file binary is what it's failing on. Okay, so I know generally enough about how SQLite dict is working to understand why it would complain on that. It has to be a string for the key. And if for some reason it's not a string by the time it reaches here, it won't be able to be used as a It's a database key. So I can actually go over here to where we were using it here. And I can do type AP hash. Yeah, it's even though you can display it like a, oh yeah, okay, so that has to be converted into a string at very least. Although that probably has a lot of insight as to how that can be used to display the image, right? When you look at it displaying like that, black and white maybe, true, false, matrix, that's the image. That's a way to display the image. If it's true, it's white. If it's false, it's black. Something along those lines to create a little black and white thumbnail image. You know, so all we have to do is convert the that into a string where it's used as a dictionary key. Now we can get rid of the less. We don't need to see the output because I know it's going to work. So once that shows send mail there, email sent, there's two places I can show it to you. I can show it to you here. I'm going to clear all outputs and restart the kernel. And I am going to import that stuff. And then I'm going to turn off the displaying of the cats for a minute and just show you there's going to be 4 primary keys, or 6 primary keys. The 3 from the first time where I was using file names, and the 3 from the second time where I'm using the perceptual image hash as the key for the key value database. Now if I go ahead and display the cats again, you'll see the first 3 cats and then the second 3 cats, right? And another way to show this to you is to go back over here where it's accessible through the Windows file system, and once again run DB browser for SQLite. File, open database, go back into my D drive again, and load cats.db. And you will see when I go over to browse data, there are now 6 records, and it is exactly reflective of what's being seen over here as the 6 cats, each with their own key, right? So yeah, if ever the same exact cat showed up again, it would not create a new record in that database. That's what primary keys are for. That's what keys and key value dictionaries are for. They are unique constraints. The same cat will never be able to be entered into this thing more than once. And so let's schedule this to run a little bit more reasonable as a service now, to send me 3 new cats every day. Just change the scheduling, right? So this file here is just what sends the cats, and now it's been beautifully updated to put a copy of the cats into a database. In fact, I can delete that database. It's always safe to delete a SQLite database if you don't need the data, because those file locks are eliminated as soon as you're not reading or writing to it anymore, which you're not doing right after you're done with it because of the context manager. That with SQL dict to the file name as DB, that means that when it gets past this code and goes back past that outdent, the file locks are removed and that thing can be deleted again. So we will run it one more time, and you'll see the cats.db reappear there. And then when we go into the cats.db with something like this database browser for SQLite, file, open database, the D drive, cats.db, and it'll only have those 3 records, and all of them are using perceptual image hashes as their primary key. Boom. Mission accomplished, right? How beautiful is this? Now, that's pretty much the whole demo, the whole video I want to show here. But just as an added bonus, instead of triggering the service manually, which I keep doing here, I'll get rid of this one. We don't need it anymore. I will write and quit out of this file. And then I will change the scheduling detail, which, as you'll remember, clear ls. This sends cats, but that's being scheduled from the scheduler. And I'll move scheduler back up into old so it doesn't pollute this. It's a lot easier to look at. If I didn't include my logo in the email every time, I could get rid of this. These are temporary files that get replaced every time, basically. And we vim scheduler. And we will change our scheduling, which is now decorators. So the pulse every 5 seconds is probably excessive. I'll probably make a pulse go every minute. And then the send mail, which is really sending the cats. I'll change that function name to send cats. And that means I don't have to replace it somewhere else in a reference. The other way it used to be done, I used to have to replace it where it was referred to. But now that we're using decorators, you can just readily change a function name like that. So sending cats is every day at 11 seconds after, I'll just say that 5 seconds. So that'll come before, no, 11 seconds is good because we'll see the first pulse come. Oh, 60 seconds. We won't see the first pulse come. Okay, so that doesn't matter. We just schedule it 5 seconds from when the service starts. So the service will start, it will send me some cats, and then it'll start doing the pulse. And hello world is not even required here. I think that is just extra noise now. The pulse and the sending of cats is the new scheduler file. And you'll remember I have this run function which funnels things through popen, which is part of Python's subprocess library. So using their subprocess library, using the popen method, you can actually run external programs truly outside the context of your running Python. So I could use this to run anything. I could use this to run Node.js, JavaScript files, or whatever. And that might come into effect soon with browser automation, but that pretty much does it. And so we write that, we quit that, and then we see if the service is running. The screen isn't there. And since I only edited the .py file, all I have to do is start the service. I don't have to restart the service, or I don't have to reload the daemons. So it's sudo systemctl start scheduler. Scheduler without the .py extension. Screen ls, and it only auto-filled the py extension because I'm in that directory, and autocomplete is weird that way. So here's the scheduler. I can screen reattach to the scheduler. And sending email, it's already sending email. So we're going to have another 3 cats in the database. So I'll show it to you from Jupyter. Perceptual key, cat, perceptual key, cat, perceptual key, cat. Those are the first 3. And then another 3, perceptual key, cat, key, cat, key, cat. And that's 6. I will Control C out of this screen thing. Every time I Control C out of it, it's going to automatically restart because daemons, when you summon a daemon, it keeps popping back. And so there it is, having restarted again. And when I show the database this time, instead of 6 cats, there's 9 cats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe I miscounted, but the important thing here is these are perceptual image hashes. Those are perceptual image hashes of the cats. These don't change very much unless the image changes pretty dramatically. They say up to 25%. So it's a great way to dedupe images. And there you have it. That's quite a spectacular bit of capability. It's great video, but the capability represented here, how many projects could this apply to, right? You need primary keys and key value pairs. What better primary key than a short thing that represents the uniqueness of an image? It's wonderful. Use it for image deduping or just as a convenient primary key when you need a otherwise arbitrary file name or key. And by the way, when we look in my email, these things that are being sent to me now, because each time I run that, a new one gets sent, I look at the latest. I download that latest. I open that location. And the newer one is this one here because it has the parentheses. I'll get rid of these two. I will extract all. Puts them in a directory. And there is all the cats with their perceptual image hashes as their file names with the .jpeg extension. How perfect is that, right? Now I can just keep dumping them into the same directory and I don't have to worry about cat1.jpg always overwriting the last cat1.jpg. End of video. Thanks for joining me. Don't forget to subscribe. Don't forget to tell people about this. I mean, it's pretty good series of videos I'm putting out here, isn't it? So share the love. Talk to you soon.